Hi, I am Aditya, and this is my AV1601 glider project report. So here are the requirements for this project. So the glider must fit in a 16 times 16 inches square box. The glider must remain intact without breaking while testing and flight. The glider must be hand-drawn. The glider must fly at least 20 feet, and the glider must fly in a straight line. So here is the initial design. As you can see, I have used the elliptical wing design with T-shaped tail configuration. Here we can see the top view, the front view, as well as the side view. And moving on to the design decisions, I have decided to use balsa wood over other materials like cardboard and 3D printed plastic for the following reasons. The balsa wood is easily available for me at the AE Makerspace, and also it is very lightweight. It has better aerodynamics compared to cardboard and 3D plastic, and it's also a lot stiffer. And talking about the design, as I have previously mentioned, I used the elliptical wing design with T-shaped tail configuration. The material used is balsa wood, and the total weight of the glider after adding extra weight is around 31.6 grams. So here is an image of my glider on the weight scale, which shows the weight is 31.6 grams. And to find the lift and drag coefficients, we need to first find the mass of the glider and then find the surface area of one side of the wing, find the wingspan. We also need to find the average distance traveled by the glider in multiple attempts. Using this, we can find the lift and drag coefficients. So here are the measurements. The mass is 31.6 grams, that is 0.031 kg. The surface area is around 0.187 meters square. The wingspan is around 0.15 meters. The average displacement is around 20.2 feet, and the average time taken for each attempt is 1.53 seconds. The average velocity is around 3.9 meter per second. So uh, we can calculate the drag and lift coefficients using these formulas and the measurements we have. So the approximate lift coefficient is 0.672, while the drag coefficient is 0.01088. So here are the design iterations. After the first few tries with the glider with no mass, I figured out that I need to add extra mass for the glider to be stable. This is because with zero mass, as I try to throw the glider, it's not stable and it goes like all the way up and down without actually reaching the target 20 feet. So I have decided to add a bit of Play-Doh and a couple of poles and nuts as extra weight to the glider. After adding extra weight, the glider was actually very stable and was able to fly at least 20 feet in every attempt. And for testing, I have tested the glider for like around 11 to 15 times. And after adding extra weight, each time it managed to fly more than 20 feet. Here is a video of me.
You're good. You're good.
The final thoughts about this project is that I could have made the glider more stable. As you can see in the testing video, it's moving more towards right because of the uh, unequal weight mass distribution. So I could have made the glider more stable by accurately finding the center of gravity and adding extra mass at the right places and also distribute the mass accordingly. Thank you.